Okay, so I'm gonna talk about the elliptic integral of the first kind. Given that theta, the dotted theta squared is equal to 2g all over L times cosine theta minus cosine alpha, I'm asked to show that the dotted theta squared is also equal to 4g all over L times sine squared alpha all over 2 minus sine squared theta all over 2 using the identity cosine u minus 2 sine squared u all over 2 and then integrate. Next, I'm also asked to show that p is equal to the square root of L over G times the integral of d phi all over the square root of 1 minus k squared sine squared phi, where k is equal to sine alpha all over 2, while letting sine theta all over 2 is equal to sine alpha all over 2 sine phi. So, to show that the dotted theta to show that the dotted theta squared is equal to 4g all over L times sine squared alpha all over 2 minus sine squared theta all over 2, we will first begin with the original equation and then substitute the identity. So dotted theta squared becomes 2g all over L times 1 minus 2 sine squared theta all over 2 minus the quantity 1 minus 2 sine squared alpha all over 2. Next, cancelling, since 1 cancels out, the equation becomes 2g all over L times the quantity negative 2 sine squared theta all over 2 plus 2 sine squared alpha all over 2. So factoring 2 out, we get dotted theta squared is equal to 4g all over L times the quantity negative sine squared theta all over 2 plus sine squared alpha all over 2. Integrating this equation, we get knowing that the dotted theta is just equal to the d theta all over dt quantity squared is equal to 4g all over L times sine squared alpha all over 2 minus sine squared theta all over 2. We get d theta all over dt just equal to the square root of 4g all over L times sine squared theta sine squared alpha all over 2 minus sine squared theta all over 2. So dt now is equal to d theta all over the square root of 4g all over L times sine squared alpha all over 2 minus sine squared theta all over 2. So integrating both sides, we get d is just equal to the integral of d theta all over the square root of 4g over L quantity sine squared alpha all over 2 minus sine squared theta all over 2. So introducing now the equation sine theta all over 2 is just equal to sine alpha all over 2 sine phi, should get d theta. So deriving both sides, we get 1/2 cosine theta all over 2 d theta is just equal to sine alpha all over 2 times cosine phi d phi, since sine alpha all over 2 is just a constant variable. So d theta now is equal to 2 sine alpha all over 2 cosine phi d phi all over cosine theta all over 2. So knowing the identity cosine squared plus sine squared is just equal to 1, we can transform the cosine quantities into functions of sine. So doing so, we get d theta is equal to 2 sine alpha all over 2 times the square root of 1 minus sine squared phi d phi all over 1 minus sine squared theta all over 2. So transforming again sine squared theta all over 2, we get d theta is just equal to 2 sine alpha all over 2 times the square root of 1 minus sine squared phi d phi all over 1 minus sine squared alpha all over 2 times sine squared phi. Letting k be equal to sine alpha all over 2, since it's just a constant, we get d theta now is just equal to 2k times the square root of 1 minus sine squared phi d phi all over 1 minus k squared sine squared phi. Also, so from the original equation of t, which is the integral of d theta all over square root of 4g over L times sine squared alpha all over 2 minus sine squared theta all over 2, transforming sine theta all over 2 into sine alpha all over 2 sine phi, and transforming sine alpha all over 2 into k, we get the integral of d theta all over the square root of 4g over L times k squared minus k squared sine squared phi. So, factoring out k squared and 4, we get the integral of d theta all over 2k times the square root of g over L times 1 minus sine squared phi. So, substituting d theta to this to the to the equation of t, we get t is just equal to the integral of 2k square root of 1 minus sine squared sine squared phi d phi all over square root of 1 minus k squared sine squared phi all over 2k times the square root of g over r quantity 1 minus sine squared phi. So clearly 2k cancels out and the square root of 1 minus sine squared phi. So we are left with t is equal to the square root of L over g times the integral of d phi all over the square root of 1 minus k squared sine squared phi. Thank you. Oh, 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 oh.